This is going to be a very short lecture, and most of the time, myself and Mike, when he comes back, we'll walk around and answer questions. Treat this more like an office hours or a lab lecture. If I got just a little bit of content we'll get through, should take 5 to 10 minutes, and then we'll get to the next part. So the majority of this, I got kind of a beast of a lecture question here. I don't think it's overly complex, but it is fairly large for a lecture question. In by similar fashion, since it is a larger one, you get till tomorrow night to finish it, and it's worth 20 points, so we have some time. I'll talk about this a bit more after just this couple of slides of content, but let's get through just a little bit of content first. And of course, I highly encourage you, you'll manage your own time the way you want to, but I encourage you to use the lecture time to work on the lecture question. Sit in, lecture, ideally get it done before you leave, and then just enjoy your weekend, or maybe work on a calculator over the weekend. But get it done, at least spend this time during lecture to be able to work on this question. All right, so I got 2 slides of real content. Let's go through these. I just want to kind of wrap up this state pattern discussion that we've been having. We had 2 lectures on this. We had the lecture question on Monday, the lecture question today, and the calculator, where I'm effectively forcing you to use this state pattern. And we've learned about it for 2 full lectures here. We saw the state pattern applied to Bruce Banner. We saw the state pattern applied to the jumping mechanics in the jumper game, and in the lecture questions that I mentioned in the calculator. So after all that, let's kind of reflect a little bit on what we've seen with this pattern, mostly going over the pros and cons. So the pros, why did we learn about the state pattern at all? Why did we even bother? Well, if we have an object, or we have a class that we're going to instantiate into objects that have very different behavior under different circumstances, the state pattern can be used to really simplify the design and the implementation of all of that different behavior. So we create these different states that the object can be in, and then the object just defers to those states for its behavior. So if we want a lot of different behavior, we implement different states for each behavior, and then work on the state transitions to see when that object transitions between the states. Now, when we have it split into these states, each method that we implement is only worried about one specific input and under one specific state. So if I'm in this state and the user pushes a left button, what do I do? If I'm in this state and the user pushes volume up, what do I do? If I'm in this state and somebody makes me mad, what do I do? How do I react? How do I behave? How does this object behave? So each method that we write when we're using the state pattern gets pretty simple. This applies to your calculator as well. Once you have your design for your calculator, once you have all the states that you want to be in, once you have your API written, when it comes to actually implementing the methods, there's not a whole lot to implement. In my calculator solution, I don't think I have a method that's more than 5 lines. It's really, each method should be pretty simple, small chunk of behavior. If I'm in this particular state and somebody hits the equal button, what do I do? What does the calculator do? How does it respond to that exact input? Once you have the design implementing the methods, not really that big of a deal. So with the state pattern, it's much more of a design question. How do I design my software as opposed to how do I actually implement this software? Because the implementation should be easy if you have a good setup and a good design with the state pattern. And finally, when we want to add more states, when we want to expand on this, we did this in both lectures. Both lectures, we set up the state pattern, set up our program, and then we extended that behavior. And each time we extended that behavior, it was about as much work as it was to write that first state. Adding a new state, it's as simple as extending the state object again, the state abstract class again, implementing the API for how I should behave in this state, and then adding in any necessary state transitions. How do I get into the state, and getting back out of the state, how do I transition from those states? I don't have to touch any of the other code except adding in the state transitions, and I can leave most of my code unmodified. So if I want to add that 100th behavior, if I got an object that can be in 100 different scenarios, or 99 different scenarios, and I want to add that 100th one, that's as much work as it was to add that second behavior. And that's one big thing that we gain with the state pattern, is if we have a lot of different behaviors in one object, we can add all those different behaviors. Once we have the setup of the state pattern, it's very easy to expand that into new behaviors and new in new features in our software. We can add those quite a bit. But there are also some cons here. This isn't just you should use the state pattern everywhere. Now that we know this is something we'll use all the time. That's absolutely not the case. We have some pros, but those pros are if you have wildly different behavior in the same object under different circumstances. If you don't, if you have just either a few states, maybe you only have 2 states, or even 3 in some cases, or maybe across those different states, the behavior doesn't really change all that much, you're probably a lot better off just throwing in an if statement, having a few conditionals, if, else, and modify your behavior based on that. If the behavior isn't changing significantly, if it's just a small change in behavior, it's usually better off to just throw an if statement maybe in the middle of a method that's doing some work here that changes based on state, and then some more work here. Maybe just add an if statement right in this middle block that changes that little bit of behavior. So if we don't have a very wildly different behavior, or just a few states, probably not the best idea to use the state pattern because you're just going to add complexity without really getting the benefits of the state pattern. And also, this can be, especially if you're not leveraging the very different behavior, if you're not really hitting that, just having more classes in your code, or more objects if you define your state as objects, just having more object orientation in general can increase the clutter of your code. I'm sure you're seeing this with your calculators, you've seen this with Monday's lecture question, you'll see it with today's lecture question. The project structure looks a lot more complex. You have one class, instead of just having one class with this behavior defined, now that one class comes with an abstract class and then another class for every single state that it can be. If you just glance at the directory structure, that looks a lot more complicated than just stuffing all of your functionality in one state. So if you're using the state pattern when you're not really getting the benefits of it, this is adding complexity without really benefiting you, and then everybody who reads through your code, they say, oh, look at this object. How does this work? They have to read that object. They have to flip through all of the states to try to piece together what's actually going on. What is the actual behavior? Where if they just click to one file and just saw some conditionals, it might be a lot easier to understand how that object and how that class behaves under different circumstances, other than spreading your code across a lot of different states. So you have to decide, is this extra structure in my project and spreading this behavior out across multiple classes, is it worth it to be able to leverage the benefits of the state pattern? So if you have very complex and very different behavior under different circumstances, I say sure. If you don't, if the behavior isn't really complex, I'd say, shelve the state pattern, save it for another day, use it for another project or another application. So the big thing I'm stressing here, do not use the state pattern everywhere. It's a solution to a specific problem. Very different behavior under different circumstances. If you don't have that problem, don't use this solution. And this is a common thing in programming, so I just want to get this out there in general. We have a saying where as soon as you have a hammer, everything looks like a nail. Once you have a solution to a specific problem, you start seeing that problem everywhere. You start seeing the simplest program and saying, wow, that could be in 3 different states. I'm going to throw the state pattern at that. Try not to fall into a trap like that. Depending on what you're learning, it is very tempting. You just want to use that hammer everywhere. So try to avoid that for the state pattern, for everything you learn down the road. Not everything is a nail once you have that hammer. In this class, we use the state pattern, and I really forced you to use the state pattern. I want to reflect on this a little bit and look at this one from a few steps back. I did force you to use the state pattern by removing your control flow. I did this on 3 separate occasions, Monday, today, and on the calculator. This is not realistic. Your code isn't better if it doesn't have control flow. Don't start thinking down that road. I'm not saying you shouldn't use control flow at all. I am completely artificially removing your control flow to force you to use the state pattern, and I want you to use the state pattern for 2 reasons. Reinforce your understanding of inheritance and polymorphism, because you got to use some inheritance and polymorphism to have that state-based class and have concrete states. I really want you to understand inheritance and polymorphism, and this is a cool application that gets you to understand those concepts. And two, I want you to understand, I want you to see and get exposure to at least one design pattern. So we see the state design pattern, and by hope, at least, by the end of calculator, you should be able to look at that and say, and see how that organized your code in, I mean, maybe you're not completely sold on it, but seeing a way to organize your code in a different way than you would if I just said, implement a calculator, you can use control flow. Your calculator would look completely different if you were allowed to use control flow. So just seeing a different structure to your code, I really want you to see that pattern, and then decide for yourself. Is this something I want to use in the future? Is this something that will make my code look better? Will my programs come out better if I use this pattern? Should I be looking at other patterns? There are a lot of different design patterns out there that I just want to focus on one and hammer one down really good, instead of giving you a whole bunch of them. I've tried that in the past, it doesn't work well. It's covering like 5 different design patterns. So should you be looking into more design patterns? Did you really feel the benefits of that or not? That's really where I want you to be thinking, by showing you, here's one design pattern, here's a whole application of inheritance of polymorphism. This is why we use inheritance of polymorphism, because it enables us to use more different approaches in our programs, like the state pattern. But it's not necessarily always the solution, and that's why I had to force you to use the state pattern by removing your control flow. Okay. Any questions? This is my last slide on the state pattern. Any questions about the state pattern in general, or anything we've covered in this last week or the last 5 weeks? I believe it's 5 weeks into the semester already. It's crazy. Any questions? Yes? So I tried to show this in the last lecture as well. So how would I begin designing with the state pattern is I would go to them 3 bullet points, and this is, so the lecture question on Wednesday, I was trying to get at this, and it's hard to get at as much as I wanted to, but going through those 3 bullet points, what are the methods that are going to change? What's the behavior that changes based on the state? What states can I be in? And then in each state, what are the transitions between them? So if I'm looking at, we might as well start talking about the lecture question. We're looking at a lecture question like this. I'm looking at what behavior is changing across the states. So in this one, we'll have, the methods are given for you here. So we have the API already, but that's the first thing I'm asking. What are the methods that can be enacted on this? And when they're user inputs, I like to stick with just the user inputs. That's what we can do. For this, the user can hit volume up, volume down, mute, and power. And I want one output of this. So very similar to the calculator, we have one output function, which is current volume in this case. It's display number in the calculator, but it's the behavior that we want to observe after pressing those user inputs. So I'm going to look at those, get my API first. I usually like to start there. Once I have my API, I'm looking at each one of these methods, and I'll look at when should the behavior of this method change. And then for each change, I'm drawing a different state. So since The calculator is very relevant. With calculator, I know there's when I'm hitting a number button, there's two different things a number button can do in my calculator. There's two very different behaviors it can do. I can hit a number button and it can add to the left-hand side, or I can hit a number button and it's going to add to the right-hand side. So immediately I'm thinking two different states there. I don't want an if statement. If I'm working on the left-hand side, do that. If I'm working on the right-hand side, do this. I'm going to have two different states because there's two different behaviors that I can observe. So right there, I know I need at least two different states. And then and then any other situation, I gotta think, is there a situation where that number button can have a different behavior? Well, if I hit a number button right after equal, I'd say that has a different behavior. I won't give away too much of the homework here. If I hit a number button right after a operation, that's gonna have a little bit different behavior too. It's gonna add to the right-hand side, but it also changes the state of the calculator. It changes what the calculator is going to do next. So I'm looking at each one of those methods and thinking, and for the calculator, again, the API is given for you. It's all the buttons that can be pressed. That's your API. And then each button, is it going to behave differently under any different circumstances? I'm going to look through the spec sheet and see, okay, will that button ever behave in a different way than I expect? Like the clear button, that's going to clear and return to the initial state. Is there any situation where the clear button will do something different? I don't think so. So clear button is always going to have the same thing, do the same thing. That's not going to create any new states for me. An operation button can have a few different functionalities based on the state. So I got to think what each different piece of functionality is going to have to go in a different state. So once I have all my states, then I'm starting to think of the state transitions between them, figure out how to transition between the states, and then the easy part of implementing the API for each one of those states. Okay, if I'm in this state where I'm building a right-hand side number, if I hit a number, I should add to the number that I'm building. If I hit the equal sign, I should compute the current operation with the left-hand side that I have stored and the right-hand side that I'm building with the operation button that was pressed. I should compute that. If I hit another operation button, I should compute that and then start the new operation. And in that case, the displayed value, I believe, is undefined and should not be tested for that one. And the decimal button should have functionality similar to double jump that we saw. And clear button will always have the same functionality. So once I go through that and think of all the different behaviors that I can get for each API method, I'm going to split them into as many states as I need to capture all of that different behavior, draw that into my state diagram, figure out the state transitions between all them, and then implement all the methods. Is that more of what you were getting at? Okay. Yeah, but I like to start with the API, look at each API method to figure out what different behavior it should have. And at worst, each different behavior for each method will need its own state. So I need at most that many states, and then I can start collapsing them down. Okay, these two behaviors of this one API method, those will be in the same state. It'll always be the same situation. I can start combining my states and start trimming them down. And then worry about the state transitions. And importantly, when I'm in if I start mashing buttons on my calculator and I'm in this state pretty far away from my initial state, when do I have a transition to a state where all of the behavior is equivalent to a state that I already have created? Now I have a state transition that's going back to something that already exists, and I can kind of stop that chain of states, if that makes sense. I don't know if I worded that properly, but once we can have a state transition to a state that already exists, we can start trimming down instead of continuing to create new and new states. All right, so let's look at this lecture question a bit. Here we want to be able to control, any other questions before I go into it? Yeah. Question? To differentiate between states and behaviors. So each state is where you have a different set of behaviors from the API. And I would worry about the states before that specific behavior like once you have all your states, then you can go into those states and say, for each API method, what exact behavior do I want? And if that's ever different, or if you're ever tempted to use a conditional, you know that that one state should probably be two states. All right, so we want to build the control for a television. We have a remote control that has 4 buttons on it: power, volume up, volume down, mute. And we want this behavior from the spec sheet, which looks like a lot, but if you think about how you would expect those buttons to behave, I'm just trying to spell that out in the most detailed, specific way possible. But I tried to get just how we would expect a television to behave. So we want to simulate this TV, get in a package named TV, a class named TV with capital T and V, no parameters for the constructor with these methods. This will be your API. You should be thinking all these methods, every one of them should defer to your state. So your TV class should just be these methods and then defer to the state for all the functionality. And a test suite named test TV in that same package, which is going to do all the testing. So we do have functionality and testing. If you're following the pattern, I don't know how explicit I made it, but Monday I gave you the state diagram and everything, and I said, I gave you all the design, and I said implement the methods, implement the states and methods. On Wednesday, I said let's not worry about implementing, but do the design the states, design that state diagram, and just tell me about your design. Now today I'm asking you to do the whole thing plus testing. So here's a spec sheet: design, implement, and test. We're doing all 3 things today. I didn't have you do testing and isolation, so I'm tacking that one on here. And finally, let's look at this spec sheet. So what do we expect? What behavior do we want out of this? TV initially off. When we're off, the volume should be 0, but not necessarily the volume of the TV. I found this was a little tricky to word in the document, so I want to make sure I'm clarifying this one. The initial volume of the television is 5, so we're starting at volume 5, but if the TV's off and I call current volume, it should return 0. But as soon as I hit the power button to turn the TV on and call current volume, I should get 5 from that. If I decrease the volume to 2 and turn the TV off and call current volume, since the TV's off, I should get 0. But as soon as I turn it back on, this 2 should be remembered by the TV, so it should be stored in a state variable somewhere. When I turn it back on and call current volume, I should get 2 back. I should get that stored 2. So the volume should be persistent even while the TV is off and even when the TV is muted. So starts at 5, TV starts off, volume up, volume down do nothing at all, it does not affect the volume, and I get current volume of 0. I can turn the TV on or off with the power button, so the power button has 2 very different behaviors based on the state. Volume up is going to increase the volume by 1 to a max of 10. So we do have a situation where if the volume is 10 and I hit up, the up button should do nothing, but if the volume's less than 10, it should increase it. I'm saying if a lot there, it seems like a conditional. So we got to do that without a conditional. If I'm going down by 1 to a minimum of 0, so I should never get a volume of -1. Mute, of course, mutes the TV when it's muted. The current volume should return 0, but as soon as I hit volume up, volume down, or mute, I'm going to go back to an unmuted state, and the volume that the TV was at is going to be retained. And notably, the volume up, if I say I'm at volume 5, and I hit mute, and then volume down, when I'm muted, current volume should be 0. When I hit volume down, I'm going to be unmuted, but we're not changing the volume. I call current volume, it should still be 5. So when I'm in the mute state, I mean, if you happen to have a mute state, I'm sure you're all going to have a mute state though. The hitting volume up, volume down, or mute are all going to have the same exact functionality. It's going to transition the state, but not change the volume in any way. So volume up when you're muted does not change the volume, underlying volume in any way. And then if you're muted, so there's the potential that we could have an additional state here. I'm preventing that one. If we're muted and you hit power, the TV turns off, and when you hit power to turn it back on, it should go on but unmuted. So we're not going back into the mute state. So when you're off, you don't have to remember which state you came from, or you don't have to have two off states, off after muted, and just plain off. You don't have to have two states for that. We're going to reduce the complexity a little bit and say if you're going from off and hit power, you're always going to the on state. So we can simplify that just a little bit. We don't have to worry that we went off from a muted state. I think I got all those. Might as well say the hints since I'm in here. So max volume, min volume. You can use math.min and math.max. This is fair game for your calculator as well if you want to use methods that you know have a conditional inside of them somewhere. As long as you're not using them to run your code conditionally, that's fine. So math.min, math.max, you can get those, you can use these to get that max volume and min volume behavior without a conditional. And I already said it, but storing the volume in the TV class, that's going to be a lot easier than trying to store it anywhere else, specifically in a state variable. So then when you turn the TV off, that off state shouldn't change that state at all of the TV. The TV should remember its volume when it was turned off and go back to that volume when it was turned back on. Just the off state won't necessarily access that variable in any way. All right, that took a lot longer than I thought to go over those slides, but that's fine. So let's take the next 23 minutes here. Mike and I will walk around and answer questions, and then we'll get you started on this one.